Okay, today I'm back with a new topic, and the topic is about sets. And why do you need the set? At first, let's talk about it. So, probably you must have done relation and function. So, while showing the relation and function of a particular type of set of a well-defined objects, then we need the concept of the sets. So, that's why from the set we can show the relation between two definite objects. Sure. Set, what is it called then? For any study of geometry, sequence, and probability, etc. We need the knowledge of this set. So, this was developed by a scientist, by a mathematician, George Cantor in 1845 to 1918. And he first encountered these sets while he was working on a trigonometric series. Okay, let's discuss about this set and what is meant by it. And as I've told that, we have to show the relation between the sets of a particular well-defined objects. So it is the collection of a well-defined object of a particular kind, such as maybe a collection of numbers, maybe a collection of some person, collection of some utensils, materials, or here we have got pack of the cards and crowd of the people. So these are the things. So now across the collection. So now we have got here the four examples. Example odd natural numbers less than 10. So we have got this particular type. And if we take like this, the in particular type, which do not have got any meaning, then that is told to be as not to be as set. So yeah, odd natural numbers, these are the less than 10, these are the set. So we have got here all the numbers as finite sets. So in second, we have got the reverse of India, which we know, which is a particular type of set. That is reverse. It has given a common name to that set. So in the third one, we have been given as vowels. In fourth one, various kind of triangles. We know that. We have got about different types of triangle, scalene, isosceles, and equilateral, and right angle. So then after that, we have got prime factors up to 10 to 10. Now, these are the sets. Now we know that each of the following example is a well-defined collection of objects, is a well-defined, it's defined to a fixed object. If you look at it, then if you look at the first example, then it has been given odd natural numbers. Sure. Then if you look at the second, then it has been given a common name, that is reverse. Why is this happening? Okay, reverse. Then looking at the third, then we have the common name, vowels. Then fourth one we have got as kinds of triangles. Fifth one as prime factors. Sixth one as solution of equation. These are the common things which is a well-defined object, which we call as well-defined, defined in a fixed order. So these are the sets. Now we have been given example of other sets, particularly used in mathematics, as n means natural numbers, at z means integer that can be positive and negative from minus infinity to plus infinity, and it includes 0 also. Q, it means the set of all the rational number, and R as real number, while Z as plus as the positive integer, and Q plus as the positive rational integer numbers, and R plus as the positive real numbers. Sure, the symbol must be remembered as per through the text. So remember the symbol. Now again, the collection of five most renowned mathematicians of the old is not well defined because the criterion for determining a mathematician as most renowned may vary from person to person. Thus, it is not a well defined collection. We shall say that a set is a well defined collection. We are going to the topic now. The following points may be noted. What should be noted at this? The object, elements, and numbers of a set are synonymous terms. That means they must be similar to each other. While we take the sets like, just for example, we take sets like 1, 2, 3, 4, an apple, ball, like that, then it is not called to a set because they are not a synonymous term. They must have got the same meaning. So, for example, 1, 2, 3, 4. If we take like this, then they are all numeric character. So they have got meaning and they can be called as a set. And set are usually denoted by the capital letters. Right? While you denote the set, like in font p equals to curly bracket open, we denote it like this. So it must denote it by a capital letter all the time. So it may be anything from A to Z. One character can be given to the set. So the elements of a set are represented by small character. And the elements are represented by small character. And somewhere else you might find out in capital letter also. It might not affect the system of the set. If A is an element of set A, we say that A belongs to E. And we can write this belong sign as also like this. A belongs to A. That is, we give a Greek symbol which means epsilon. And this means epsilon. As we are writing E in our English language, we have got this type of E in Greek language also, which is called epsilon. So, it is used to denote the phrase belong to. It is used to denote the phrase belong to. Thus, we write A belong to A like this. If B is not belong to set A, then what we'll write that? We write it as A does not belong to, we will call this to A. Sorry, not A. Yeah, we have got B. B does not belong to set A. So we conclude it like this. Thus, in set B of vowels in the English alphabet, A belongs to B while B does not belongs to B. In the set P of prime number 30, 3 is belongs to P. 3 is the prime factor of 30, but 15 is not the prime factor. It is the composite factor of the 30 because 15 itself can be divided into by another number, that is from 3 and 5. So it can be called as prime factor and it can be taken as the prime factor. So here the prime factor of 30 will be 30 is equals to 1. 1 will be a prime, but we cannot call it a prime because it's neither prime nor composite. So we can write this now, and 1 is 2 divided by 2, 3, it is also prime. So another 7, no, it can't be divided. 7 others, uh, I think we don't have the prime factor for this. So 2 and 3 are the prime factor. 2 and 3 belongs to 30. This one, P set, which is P set. And 15 is not a prime factor. We don't have the set in this collection. So 15 is not belong to, does not belong to P. So now, there are two methods of representing a set, roster, tabulate form, or set builder form. Now in a roster form, we will list the elements. Just for example, sometime we may be given like this, n equals to the set natural numbers less than 10. At that time, the question will tell like this, list this in tabular form or roster form. So that's why at that time you must list that. So if that is given like this, let me list and give it a name as A. And we have talked natural number less than 10. So what is natural number? It starts with 1. 1, comma, 2, comma, 3, comma, 4, comma, then from 4 to 9. Less than 10, so it will be equal to up to 9. So these are the set of that. So another we have got set builder form. So from that, if you are given like this in set builder form, we write it in a notation. In the rotation. So in the first one we have taken from 1 to 9. So let us write down in the set notation form. So we have got the set name as A is equals to X, so that X, or what is a X? It is a set of natural number less than 10. So we write we write it as x is a natural number natural number less than 10. So we conclude it like this. So this is a set builder form. You'll be asked about these two set builder form only. So keep in mind about this. Now we have got the example. Write the solution of the equation x squared plus x minus 2 in roster form, that means in listing form. So yeah, we shall have to solve this equation at first. This may be asked. For lower classes, it may not be asked in context of Nepal. But while you go to higher classes, this type of set might be asked to solve the solution of the equations and write down the solution in the listed form. Here we have listed the solution, that is 1 comma minus 2, and you can give it a name also. And we can give it a name as equals to my 1 comma minus 2. So now here also we have told to write down in roster form. If you want to practice it, then you can practice. So let me go to set builder form. How we write this then as. Here we have given a set 1, comma 2, 2, comma 3, 3, comma 4 like this, and we shall have to write down in set builder form. So let me look at the pattern then. If you look at this first term, then we have got 1. That first term is 1, second term is 2, third term is 3. So it is having n as the variant. So look at that. When n equals to 1, the upper one numerator will be equal to 1. When n equals to 2, second term, the upper one numerator will be equal to 2. Then like this, we'll go to other number also. Then by let us look at denominator. In the first term, we have got 2. That is, it is increased by 1. In second term, we have got 3. Again increased by 1. In third term, we have got 4 increased by 1. So it will be n by n plus 1. So you can write it as x shows that x equal to n plus n. This is the SetBuilder form or notation where n belongs to what? N belongs to 1 to 6. 1 comma 6, from 1 to 6. Okay. You can write down like this also, or you can write down like this too. So now these are the example. You can try it. I'm leaving this as your work. So if you have any problem, then you can comment down so that I will send you the whole PDF or whole other messages declaring this or making you learn this problem. So now, which of the following are said? Justify your answer. Now let us determine which one is said at first. Let us determine here for examples. Now if you look at the first, the collection of all month of a year beginning with the letter J. If you look at it, then it is specific. That means it has been given a specific name, that is month of a year. So it is a set beginning with letter J. Look at it. What do I got? January, June, July. Yes, it is a set. First, we can conclude this as set. So now, second one, the collection of 10 most talented writers of India. Yes, it is also specific. We have both talented writers. So it is also called as set. A team of 11 best cricket batsmen of the world. We can write down this. So you can conclude if it has a specific answer to the set, then you can conclude it as a set. So you can do it by yourself. So now here are some exercise. Now we have got types of set. Let us go through it in another video.